All right, so this concept is just like the other video. It's just a little bit, has to do more with factoring. So when I'm looking at my denominators here, okay, you could multiply them together. But that's going to give you something pretty big. So before we do that, sometimes it's way easier just to check and try and factor. So in the first equation, I'm going to try to factor the denominator by taking out a GCF. Okay, now it's a little easier to say, okay, well, this is 5 times k minus 2, and then this one's k minus 2, so the only thing that's missing, so that they're like denominators, is if this was being multiplied by 5. So if I do that on the bottom, I just have to do that up top. Okay, now both my denominators are the same, so now I'm going to go ahead and subtract. Okay, I'm just going to subtract the like terms, so I get k squared minus 4. Okay, now there's a reason why I'm not distributing the 5 into the k minus 2 is because you're actually not done. This is not the answer. Because if we look up top, we say to ourselves, okay, this is actually a difference of squares. Okay, because I have a square, and then there's subtraction going on in between it. So I got to factor that to k plus 2, k minus 2. And now, okay, this k minus 2 that's on the bottom can cross out with the k minus 2 up top. And I'm left with k plus 2 over 5. So it's the same thing that we did on the last video. It's just a little bit more, closer to the algebra 2 stuff that we're actually doing, okay? Dealing with factoring and trying to make sure that we never leave something that's, can be factored more. Okay, for this example, I look and say, okay, I can't really take out a GCF here, but I do have a trinomial with your coefficient of your squared term being 1, right? Your a is 1. So in order to factor it, you would just say, what are my factors of my c term that adds up to b terms? What are my factors of 24 that add up to 11? Okay. So that would give me on the bottom y plus 8, y plus 3. Okay, so I factored this with those two factors of 24 that add up to 11. So now, if I'm looking at my denominators, I have y plus 8, and then over here I have y plus 8 and y plus 3. So if I wanted to make this denominator the same as this denominator, I would multiply by y plus 3. Whatever I do on the bottom, I just have to do up top. And now I have 7 y plus 3. And on the bottom, I have y plus 3, y plus 8. Now that I have the same denominators, I can add. So up top here, I guess I could have just distributed the 7 in here. Let's do that so I don't run out of room. I would get 7y plus 21. So now if I add the like terms, I just get 7y plus 56. And on the bottom, I have y plus 8, y plus 3. So if you're saying to yourself, well, why are you leaving it like this? Why don't you actually just FOIL it out? Well, the reason is because, again, up top, just like in the last one, when we had difference of squares, you can take out a GCF up top. So the reason why I'm not foiling this out on the, in the denominator is because what ends up happening is I have y plus 8, y plus 3, and the y plus 8 and the y plus 8 can cross out. Okay, and I'm just left with 7 y plus 3. That is my final answer. Okay, last one for the day. I'm looking and saying, okay, obviously unlike denominators, so let's try and factor the first one here. Okay, so my a is 1, so I'm just saying what are my factors of c that add up to b? What are my factors of 6 that add up to 5? that would be 3 and 2. So on the bottom I have x plus 3, x plus 2. And now it's a little more clear. How could I make common denominators? I would just multiply this one by x plus 3. Whatever I do on the bottom, I have to do up top. All right. Why I'm allowed to do that is because what's in blue right now is just equal to 1, right? Anything divided by itself is just 1. So I'm not changing the value of this fraction here, right? So what I'd be left with is x squared minus 5 plus 3x plus 3. Or I'm sorry, plus x plus 3. So now that they are the same denominators, I can just add the numerators here. And if I'm adding the like terms, right, x squared, there's no x squared in the second fraction, so I'm just left with x squared. The negative 5 and the positive 3 would give me a negative 2. So all I have done is I have added, let's get rid of this, sorry. I've just added the like terms up top there, okay? Just clean it up so it's a little more easy to see. All right, now, again, in the denominator, I'm gonna leave it as x plus 3, x plus 2, and you'll see why in a second. Hopefully, you're looking at the numerator and saying to yourself, ooh, I can factor this. So what are my factors of c that add up to b? Because again, my a is 1. So I'm just saying, what are my factors of c that add up to b? What are my factors of negative 2 that add up to positive 1? So my numerator is now x plus 2, x minus 1. Okay, again, from these guys, right? X plus, that's a positive 2 and a negative 1, right? So that's my new numerator. Denominator is x plus 3, x plus 2. And again, the reason why I'm not foiling any of these out is because a lot of times in the end, you'll see that something's going to cancel out. Okay, and I'm just left with x minus 1 over x plus 3. Okay, and that's my answer. Can't cross out the x's, can't do anything else.